begin your test. So hello and welcome everyone to Python Foundation course. And in today's session, we'll be talking about operators. So without wasting much time, let's quickly get started. So first is arithmetic operator that we'll be talking about. But before this, let me quickly, recap what we have understood till now. And this will be with a perspective of this quick demo. Okay. So I hope everybody knows why we define variables. We define variables to store some data, and this data can be of different type. That is called data types: integer, string, list, dictionary, tuple, set, boolean. This is what we have covered, and this is how we give data to our variables. And I hope everybody remembers how this data is getting stored in the memory. We talked about that as well. Once this data is stored in the memory, next is you'll have to apply certain tasks, or you'll have to apply some algorithms using which you'll solve your actual problems, right? And what are these tasks or algorithm? These are nothing but certain operators you apply on top of your data to solve a problem. Correct? I hope this is clear to everybody. There's no doubt in this, right? Operators is another basic fundamental that defines our algorithms. That's the key of our algorithms. And what is an algorithm? Algorithm is set of these small tasks which help us solve a complex problem. Okay, so that's what we'll be talking about, operators. And after this, we'll talk about decision making. How do we make decisions? So while I'm talking about operators, I'll try to bring some decision making concepts here itself, so that you guys can understand the decision making concepts clearly. And in next class, we'll talk about loops. Okay, now that being said, arithmetic operators, comparison operators. So in comparison operators, we'll compare left hand side operand and the right hand side operand by using a operator. Then assignment operators are really simple. It's like assigning the right hand side value to the left hand side variable. And then logical operators, bitwise operators is another important type of operators that we'll be talking about. I hope everybody remembers computer understand only zeros and ones. That's why it's very important to understand bitwise operators clearly. Then we have membership operator. It helps understand if a particular element is member of our list or is a member of our dictionary. So those kind of operations you can perform using membership operators. Then you have identity operator. So this is on the memory level. In previous classes we have talked about how the variables or the data is getting stored in the memory. So similarly, if we have a single object and that object is having two variables pointing to it, then the identity of those two variables is same. So don't worry, we'll talk about this in detail, but just wanted to give you a high level overview. Now that being said, let's quickly get into arithmetic operators. So guys, I'll try to quickly cover them. In case you feel you're not able to understand something, stop me then and there, because operators are kind of easy only, because it's just that you need to understand what that particular operator does. So plus, minus, multiplication, division, modulus, exponent, and floor division. I hope all of you know these operators, but some of you might not know the last three. So let me just quickly cover the last three, and then we'll directly get into the practical implementation and then try to understand more. So basically, divide is A divided by B, where let's say A is 2 and B is 2, then the value will be 1. Similarly, if you want to do modulus, so in that case, what you do is you do this. So 6 mod 4 will be remainder of 6 divided by 4, and what will be the remainder? 2. So 6 mod 4 is 2. Is it clear? Modulus operator. This is the definition of modulus operator. So wherever you say A mod B, that means what you want to do? You want to do A divide B and then get the remainder of A divide B. That's what modulus means. Okay, I see. Guys, please type in English so that it's easier for me to understand. Thank you. Okay, I see there's a question. Yeah, I guess we are recording the session, not a problem. Fine. So this is what is modulus. A divided by B, and whatever is the remainder of A divided by B, that is the output of your modulus. Similarly, what is floor division? We'll come to exponent in a minute, don't worry. Floor division is again integral value of A divided by B. So in this case, let's say our A is 5 and B is 4. So 5 divided by 4 will give you 1.25. And what is the integral value? 1. So 1 is your output of A floor B, where A is 5 and B is 4. Similarly, 202 floor division 10. What will be the output? 20. Though if you see the output is 20.2, if you see the divide, but because it's floor divide means integral part of this. So what is the integral part of this? That is 20. So 20 is the final output for floor division. Is it clear, guys? I hope this is really easy. So you might not have a lot of questions, but still, in case you have, please ask. I highly appreciate if anybody has questions. So please don't hesitate to ask questions. And what is exponent? Let's see the symbol. Double asterisk. So 2 asterisks means exponent. Now what does that mean? 2 exponent 3. So that means multiplying 2 3 times. 2 into 2 into 2. This is also called power. Basically, this is 2's power 3. Okay, so this is how you can represent this. 2's power 3. Okay, I think this is like this. Okay, so basically, this is how you write it. Okay, let me open the tutorial board so that it's easy for you to relate. Tutorial white. Oh, sorry. Okay. So I hope everybody knows this. 2 to the power 3. This is exponent. So this is, what does this mean? 2 into 2 into 2. So the output is 8. Okay, I hope this is clear. Sir, how this? Okay, so somebody is saying, sir, what about 4 mod 2? What will be the output? So he already knows the output will be 0, but he's asking why the output is 0. So again, the definition, what was the definition for mod? A divide B and take the remainder of this. So when you try to divide 4 with 2, it will get completely divided, right? So what is the remainder? 0. So output will be 0. Clear? Yes or no? Remainder. Yes. Okay. Perfect. No. Don't get confused. Quotient or if division. No. It's a remainder. This is remainder, right? This is remainder. You'll have to take the remainder. Forget about the question. Forget about this. Forget about this. Only remainder. Okay. Goody good. Any more questions? Okay. Perfect. Fine. And subtraction, addition, multiplication, division, I guess everybody knows. So no point, discussing these. But what I'll do is I'll quickly execute this for you so that you can verify the outputs. Which one is giving us a problem? I think this one, bitwise operators. Because I was just quickly writing them before the class. Okay. Okay, here you go. So A is this, B is this, A plus B is this. Subtraction, everybody knows. Multiplication also, division also. Mod 2. Why 2? When you try to divide this by 10, the remainder will be 2, correct? So that's what the answer is, modulus. Then next is exponent, 2 into 2 into 2, 8. And then the last one, this. So as we already solved, the answer is 20. Okay. I hope this is clear. Let's quickly move to the next operator that we have here. The next one is comparison operators. So in this, what we do is we have one operand on the left side, and then one on the right side. So we compare these two operands based on the symbols or based on the operators that we have here and generate the final output. So, these operators are very useful in case of decision making, because as you all might remember, when we talk about decision making, we are making a decision based on certain conditions. So let's say condition could be if A, which is on the left hand side, if that is equal to B, then this condition will get satisfied. Let's say if student is equivalent to pass, let's say if student pass, only then certain conditions will execute. So in those cases, this operator will come in handy. Let's say greater than, if student gets marks greater than 80, then give him a toffee. Chocolate. Toffee is no, not something big. Okay, chocolate, we can take chocolate. Okay, give him a chocolate. So again, condition based on this operator, we are defining conditions. Similarly, these are mostly used in case of conditions. Now let's quickly talk about these. So comparison operator means the first one we have is double equal to. So double equal to means if the value of two operands are equal, then the condition becomes true. So if you see A equal B, that means if both these values are equal to each other, then the output is true, otherwise false. Similarly, next one is if value of two operands are not equal, then the condition becomes true. If the value on the right hand side is not equal to the value on left hand side and vice versa, then this will return true, otherwise it will return false. Don't worry if you're not able to understand this one. We'll talk about this in a minute during our practical session. Next is this, greater than. Okay, I see a question. Sir, are these operators same as C operators? Yes, so somebody saying, sir, are these operators same as C operators? Definitely, they are same. So the difference you'll see is in here, membership operator and identity operator. These are different from C. Others like bitwise operator and arithmetic comparison, these are similar in all other programming languages as well. Okay, and then this is greater than equal to. What does this mean? In case both the operands are equal or this one is greater than the right hand one, then it will return true, otherwise it will return false. So basically these operators deal in true false. That's why I was saying we mostly use them in our conditions. Okay, let's quickly dive into the practical implementation of these. Let me remove this and yeah, till this point, and this one till here. So we'll try to understand these operators, and then we'll get into decision making. Along with these operator itself, we'll also cover decision makings, so that we don't have to spend too much of time on other things. Okay, let me comment this for a second. Fine. So let's say you have a equal to 10 and next line b equal to 20, and you say a equal b. So what do you think will be the output? It will be false. Why false? Because they both are not equal to each other. Let's say if it was 10, the output will be true. Why true? Because they are equal. Correct. What is next? Greater than equal to. What will be the output? True. Why? Because a is greater than, or it should be equal to b. So it is equal, so that's why we are fine. Let's say if it is 11, then again it's true. But let's say if b is greater, in that case we'll get false. Okay, clear everybody? Next, this one, false. Why false? Because a is not greater than b. But if we do this, then it will be true. Why? Because a is sorry guys, a is less than b. So that's why you get true. And let's say if you do this equal to, then again you will get true. But if you do this, then you will get false. But if you do 12, again you will get true. So is it clear, everybody? Any questions? Or there's one more, not equal to. This will return true when these two are not equal to each other. Let's say in this case it will return false. But what will happen in this case? What will be the output in this case? Guys, please respond in the chat so that I can understand if you guys are understanding this, or do I need to repeat this concept? I know this is easy, but still just want to verify. Oh, somebody's saying true. Okay. True. True. Oh no, somebody's saying false. No, false. It will be true. Why true? Why true? Because this operator says, the definition of this operator says, if A is not equal to B, then good, then true. But if they are equal, then return false. When will this return false? When these two are equal. Okay, let's say in this case, equal says I'll only return true when these both are equal. So now this will return true. But this is opposite. Not equal to is opposite of equal. These are opposite. Equal is opposite of not equal to. Okay. Am I making sense? Perfect. Yeah, got it. Cool. Fine. Okay, good, that's good. So you understood? This will check for equality. If these two are equal, then it will return true, otherwise it will return false. But this will return true if these two are not equal. In case they are equal, it will return true. It will return false. Let's say in this case, it will return false. Okay, perfect. Okay, somebody is saying, sir, can you talk about operation preferences? So to be honest, if I get time, I'll talk about it at the end. Otherwise, please Google it. You'll directly get it. You don't have to, get into that. You just directly go and check out the preference. You'll get a list around that. But in case I get time, I'll definitely discuss it at the end. So for others, you guys can also, go and check out the preference. Let's say, will exponent be used first, or will subtraction will be used first, or plus addition will be used first? Let's say there is a case. Let's say in this case, what will be the output? So this is what somebody is looking for. So what will be the output in this case? Let's say if I want to print, what will be the output? So in this case, it's very important to understand the preference of which operator will be, used first. But one very important thing that I'll tell you is that's interesting. But this theoretical concept you can get from internet, which one will be used first. I'll tell you how this is actually implemented. Okay, what happens is these are implemented using a stack. Okay, in stack. So what happens is in memory, these all operators will have certain preference, and that preference is stored in a form of stack. I'll show you how stack looks like. Okay, this is how stack looks like. Stack, like your plate stacks, right? You stack your plates together. So the one that is at the bottom will be consumed at the end, because if you try to pull this plate, all other plates that are at the top will get broken, or will slip. So this one will be used first. So similarly, preference of these operators is implemented using stack. Stack is what? Stack is a data structure. Data structure. Why I'm telling you these concepts to you guys? Because I want you guys to go and Google these concepts, data structures. Go and Google data structures, and also read about stack data structure. What is stack data structure? Okay, and how is it used in operator preference? Okay, please go about it and read. Okay, great. So I'm talking on the memory level. So somebody is messaging, sir, it's baud mass. Fine, it is baud mass. That's a rule. But How do you implement that in computer? Does computer understand board mass? Will computer understand A, B, C? We talked about that, right? It won't. But will understand these data structures. So you have to implement different. Guys, please remove
Over there.
okay, thank you. Okay, so this is how you can implement. You can read about this. You'll find a lot of content around this. Fine, let's move on. Stack, S-T-A-C-K, stack. You can read about queues as well. When you're reading about stack, okay, read about queues as well. Queue, stack and queue. These are two data structures, stacks and queues. Okay, guys, if you have understood these, comparison operators, let's quickly try and solve a practical use case, which will also talk about decision making. Let me quickly remove these for a minute, or let me comment them. So now they're commented. Okay, don't worry about these. These are hidden now. You have to focus on them. So this is what you have. R equals to 6. Let me remove this also. So please follow me properly. We have already talked about comparison operators. Let me quickly show you logical operators itself here itself, and then we'll start talking about decision making also here. So under logical operators, you'll see there are 3 operators: and, or, and not. What does and say? And says this: if both the operands are true, then the condition becomes true. If any of the two operands are non-zero, basically true, okay, 0 is false, okay, so remember that non-zero means true, then condition becomes true. What does that mean? Let's say this is non-zero and this is 0, then also that will turn true. Or any of these should be true, then the output will be true. So it's based on the literal meaning of or, and is based again on the literal meaning of and. If both are true, then the output will be true. If both the operands are true, then only the output will be true. If any one of these is false, then the output will be false. And again, this one is opposite. If the output is true, if the input is true, not will make it false. If the input is false, it will make it true. Okay, this was pretty easy. Let me go back to the screen, and slowly we'll try to build this concept of decision making using these two operators. Okay, what is the time? Okay, we still have time. Fine. So let's say if is what? This is for decision making. If R equal, everybody knows now what is equal. If R becomes equal to 1, then this condition will become true. And if this condition becomes true, we'll print chocolate. If it doesn't, we'll print nothing. Nothing gets printed on the screen. Why? Because this condition didn't become true. So in this case of ours, where value of R is equal to 6, if we execute this statement, what do you think will be the output? Error. Fine, let me do this now. So what will be the output? Nothing. Nothing gets printed. Why? Because R equals to 6. So this is 6. So is 6 equal to 1? No. That means this if condition is not satisfied and chocolate doesn't get printed. But let's say if this R was equivalent to 1, then chocolate gets printed. This is decision making along with the use of comparison operator. Clear to everybody? Any questions? Guys, my aim is to make sure that everybody understands this. It's not only about 1 or 2 people who already know Python. It's about those people who don't know Python by before, and it's again for those also who are good at Python. I'll keep telling things which you might not know from my experience. So please help me understand. Are you guys able to follow, or Do you have any questions? Good, good. Somebody says, could you explain once again? Perfect. What about others? Shall I explain again or you're able to understand? Guys, please respond. Otherwise, I'll go and teach and it won't make sense for you. Oh, no, 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 no. These are not loops. Understood, sir. Assigned operator is equal to equal operator. No, assigned operator is different. Understood. Okay, okay. Few people want me to explain it again. Fine. So guys, first of all, let's quickly understand assignment operator is different from comparison operator. This is the assignment operator. What it says, assign values from right side operand to left hand side operand. Basically, this is the assignment operator. Single, equal, and double equal to talks about comparison. This is comparing both the operands. Single equal to talks about giving the value. So whatever you have on the right hand side will be given to the left hand side. Okay. So if we come here, you remember variable R. Oh, bad R. R will be equal to 1. That means 1 is assigned to R. And when you do this, R equal 1, now you are doing checking. Okay. Excuse me for my handwriting. Okay, it's difficult to write with mouse. This is check. Checking. You're checking is R equal to 1 or not. Am I making sense? Here we are testing it, but here we are assigning. Okay guys, is it clear? Single equal to means assigning this value 1 into R, and here double equal to means we are testing if this R is equal to 1 or not. If this is true, the output will be true, and this is assigning. In the memory, R will have 1, R will have 1, and this is an address in memory. Remember? So this is for assigning and this is for testing, checking. Clear? Is this thing clear? So somebody is saying, sir, what happens if we don't write if? Nothing happens. If you don't want to write if, don't write. Remove it. Do it like this. R equal 1 and R is equal to 6. It will return you true false. It will print true and false. But I was just trying to give you a practical example so that you can understand better. Okay, once we start talking about decision making, I don't want you to guys, I don't want you guys to be blank and keep asking, sir, what is decision making? I want you to make sure that you understand decision making from here itself. Is it making sense? Here I'm assigning 6 to R. Once 6 is assigned to R, here I'm checking if R is equal to 1. And I get false. Why? Because it says, no, R is not equal to 1. But if you do this, then it will return you true. Or if you make this as equal to 1, then it will become true. Or let's say if you do this, B and A. Now I'm trying to make it a little more complex, but this will make more sense. R equals to A plus B. So what is A plus B? A plus B is 6. And when you do the comparison over here, you will get true. Clear? Is it clear, guys? Okay, thank you, Sandeep. It's clear to Sandeep. What about others? Realme. Who's Realme? What's your real name? Realme? Good, fine. Yeah. Good, perfect. So, okay, Kirti, thanks. Fine, great. Forgot. What was I going to speak? Good, guys, good. So whosoever asked this question, thank you very much. You helped a lot others because a lot of others also didn't get this concept clearly. And I made an assumption that you guys understood it. So Thank you. Okay. Now, if it is clear, let's go back to the decision making concept. Yeah, and guys, same thing applies to this greater than equal to also. Okay. R is equal to 0. Again, is R greater than or equal to 1? What will be the output? Quickly, what will be the output? Guys, please reply in the chat. What will be the output? False. Good. Perfect. False. Good. Yes, correct. Now, if I make it this 10, then what will be the output? 10. R equals to 10, and print R greater than equal to 1. Good. It will be true. Okay, yeah. This shows that you guys are understanding this. Fine. Now, a tricky one. Not equal to. What will be the output now? Tell me. Oh, people are saying true. Really? Will it be true? Somebody saying false. Okay, people are saying true. True. Let's see. True or false? I guess it should be true. Right. So whosoever answered it as true is correct. The answer is true. Why it is true? Because 10 not equal to 1. Yes, it is not equal to 1. 10 is not equal to 1. Correct. It's not equal to 1. You are right. That's why answer is true. Okay. And if I make it equal, then the output will be false. Why? Because no, they are not equal. Clear? I hope it is. Let's quickly, jump onto this explanation of ours. Okay. So if R equals to 10, and instead of adding print here, now I'm adding this to my if decision making. I'm adding decision making here. So this is the syntax of decision making. If and this condition. What will this return? I hope everybody knows what will this return. This will return false, and because this will return false, if will become false, and because if return false, then this won't get executed. Correct? But let's say if this becomes true, then if this condition becomes true, so it's like your parents saying, if you will bring marks greater than, sorry guys, excuse me please. Okay, where was I? Yeah, here. So if you get more than or equal to 80%, then you'll get a chocolate. So it's a condition. If this becomes true, then whatever code you have here inside this block, let's say you have print good performance, okay, or whatever after this, let's say you have C equal to C plus 1, okay, and you have a few more print statements, print C. So all these statements will get executed if this condition is true. Clear? Yes, no? No guys, my neighbors have dog, and that too 3 dogs. I don't know what these guys do with the 3 dogs. So somebody is asking, sir, do you have dogs? No, it's not mine. Fine. So if R equal to 1, and if it is true, all these statements will get executed. And what do you think? Will I get an error when I execute this or not? What do you think? Will I get an error when I execute this? Here the question clearly, will I get an error when I execute this? No. Some people are saying no. Yes. Few people are saying yes. So I think people who are saying yes, they are correct. Why will I get an error? Because C is not defined. Okay, so I'll have to define C. Again, this is little advanced, but for those of you who didn't understand this, don't worry. It's just that before using any variable, you'll have to define it, right? Otherwise, how will my interpreter get to know what is the value of C? So you'll have to define it before using it. Okay, so now when I execute this, I won't get any error. And because this condition was true, now chocolate gets printed. Good performance, basically abbreviation, performance gets printed. And then C equals to C plus 1, my task, mathematical task, gets executed and it prints the value of C, which was initially 0, now it becomes 1. Clear to everybody? Perfect. I see a lot of you have given the right answer. That's yes, it will give an error. Fine. So that means you all understood this. So this was about comparison operator along with its real-time use case in decision making. Now let's make this condition little complex. I hope everybody has understood what is happening here. What is if doing? If is looking for the condition that we have over here. If it is true, it will perform these tasks. If it is false, it won't perform these tasks. Now let's add logical operator to it. What is logical operator? We have 3 logical operators: and, or, and not. Okay, so let's add and here, and here we have equal to, or no, not equal to. Here we use greater than equal to 0. So now this, I guess everybody knows. This everybody knows. Why? Because this is part of comparison operator, and you guys know this by now. This will return us this highlighted one. This will return us true. This will return us true because R is greater than or equal to 0. Yes, it is greater than, so fine. Yeah, it will return true. This will return true. Okay, yes, I understand. You guys understand. Good. But this is a logical operator. What is the definition of logical operator? If both the operands that are there on the left hand side and right hand side, if they are true, then I will also return true. Otherwise, I'll return false. So here, if you talk about the preference, because these operations are in brackets, so they'll get executed first. So it will look something like this: true and true. So if these two are true and you have AND operator in between, AND operator says if both are true, only then I'll make it true. So this entire condition becomes true and this will get executed. Let's try it out. You see, all of this got printed. All of this got printed. Correct. So somebody is saying, sir, if R equal to 1, then obviously R will be greater than equal to 0. Yeah, you are right. You're correct. But it's just for the sake of demonstration. Okay. Don't worry. You can take C over here. Let's say if you're not happy with R, let's take C. Happy? So yeah. So you guys understood? You guys understood the logical operator? The actual use of logical operator. This is the actual use of logical operator. Fine, good. Oh, what's parivartan? Good, whatever. That's good. Next is OR. So what is the definition of, let's complete AND first. Now, if I do this, then what happens? Will this get executed or not? Will chocolate, good performance, and 11 get printed or not? Please reply in the chat. What will happen in this case? What will happen now? Will it get printed or not? Yes or no? No, it won't get printed. No. Or yes? No, no. Perfect, 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 guys. People are saying no, it will not get printed. You are correct. It will not get printed. Why? Because now this becomes false and this becomes true. And true and false in case of AND will become false. That's why it won't get executed. Cool, guys. You're understanding. So this will become true and false. Oh, false. And that's why it won't get executed, because in case of and, this won't allow. But if I make and as or, then what will happen? Then it will get executed. Why? Because or says either of these, either this one or this one. If any of these is true, I'll make the entire expression as true. I'll consider this entire expression as true. And then if I execute, this will get executed. Clear? No error. Perfect. No error. Yes. Okay. Goody good, guys. I hope all of you were able to understand this. If not, again, please answer or please reply or ask questions in the chat. I see a couple of people have started asking questions in the chat, and I know they are understanding, but I see there are 44 people. If you remove me, then we have somewhere around 42, 43 people constantly, listening to these things. So please, guys, please try to take part in answering. In case you're not able to understand, please ask questions. But you're able to understand and you're not interested in asking questions and you're not interested in answering the questions, then that's completely fine. That's okay. But please, if you're not understanding, please ask questions. Okay, good. Now let's talk about not, and then we'll, we have just 20 to 10, 15 minutes more left with us in today's session, and I want to complete these operators. So let's quickly try to close it. Not. So what will be the output? It will be false. Why? Because this is true, and not will convert it and make it false. But let's say if this was 10, then it will get printed. Why? Because this becomes false now. This is false. That value became false. And what is the responsibility of not operator? The responsibility, the role of not operator is to convert true into false and false into true. It negates the effect. So false will become true and this overall will become true, and you see we got our output. Okay. Okay, guys, I'm hoping this was clear. I'm moving to membership operator, then identity, and at the end we'll talk about bitwise, because bitwise is little important, and that's why I want to cover it at the end, so that you can focus on bitwise operator. Okay, yeah, I think we have no questions, so we can continue. Comment this out. What happened? Oh, this is commented. Yeah. What's happening? Okay. Fine. So this is membership operator. Let's quickly see what membership operator says. Membership operator says it has two things: in, not in. In means evaluates to true if it. Sir, could you why are you using 3 dot before completion of each program there? Okay, somebody is saying, sir, why are you using 3 dots before each and every program? So I'm using these 3 dots to comment the code, block of code. So 3 dots over here and then 3 dots over here. So what it does is it comments this entire block of code. If I want to comment a single line, I'll use hash. Okay, I talked about this. But if you want to comment out the entire block, so add these 3 dots. Basically there are 3 quotes in the start and then in the end. So the entire block will get commented, and your interpreter won't consider it while executing it. And similarly here, because I want to comment the code that is written below, so that when I execute this code, I get the answer for the code that we are talking about. So that's why I use 3 dots. Thanks for asking that question. Okay, good. I hope you understood that. Evaluates to true if it finds a variable in the specified sequence and false otherwise. So what it says, it takes two operators again, operands, right side and left side. And if this says x in y, here in results in a 1 if x is a member of sequence y. So basically what it says is, let's say you have this string, okay, which is s, and then you have a list like this. And if you want to use your membership operator, which is in and not in, so in case of in, what will happen? P in S, as I already said. Python is very close to English, okay? So it's very easy to understand its keywords. P in S. What does that mean? Is P part of S? Yes, it is. So this will return true, and you already know that. Z not in S. Z is not a part of S. That's true. Z is not part of S. That's why you again see true. Clear? Correct. So somebody is saying, sir, the output for this membership operator will also be true and false. Exactly. It will always be either true or false. It's same like comparison and logical operator only in terms of the output, true or false. Same for logical operator and comparison operator. They'll always give output in the Boolean format, either true or false, true or false. Similarly for membership operator, it will also give an output in form of true or false. Is this part, and where are all these things used? These operators will be very useful in decision making, and when you are using loops at that time also, to maintain the loop, you will need these conditions, because using these conditions you might have to break your loop. You'll have to continue with the loop. You'll have to perform certain tasks. So that's how you'll be able to customize and solve a variety of problem of yours using programming. Basically the idea of programming is to solve real world problems using software capability. Okay, so I hope this is clear. This is easy only. Let's take example of list. P in L, false. No, it is not there. Z not in L, true. It is not there. Similarly, if you write 2, true. This is there. This is there. Nil. This is here. So that's why you get true. Clear, guys? Any questions with this, or if yes, please let me know. Otherwise, I'll move forward. I'll move forward with the identity. Clear? Yeah, this one is easy. Good. It's clear. Fine. Again, same thing. Commenting the code that is below. So, plus there is one more way of commenting the entire code in one go. So you select this code and control / the entire code gets commented in one go. So what am I pressing? I'm pressing CTRL plus this. So if you do this on the selected code, the entire code will get commented automatically using hashes. But if you don't want to do that, you just do this. Comment. Guys, please go on mute. I see somebody is enjoying. Good. Okay, fine. So somebody is saying, sir, in strings you use single quote. Oh, what's that question? Use single quotes only for 2. Isn't that an error? So somebody is saying, sir, in this you use single quotes for 2. Is that an error? No, that's not an error. This basically represents that you have a string str2, string type 2 in the list. So that's not an error. If I do it like this, even then it's not an error. Okay, so yeah, you know guys, try these small things out on your own. That that time you might able to answer all your questions on your own. And if you're not able to get these answers for them, you can ask me in the next session, or as always, Google the problem. You'll definitely find a solution. And Stack Overflow is a very useful website where you'll find a lot of your coding, programming related solutions. Stack Overflow. Okay, identity operator. If A equals to 10, this is more on the memory level. Okay, so guys, please try to visualize this. Let me also open this so that it's easy for you to understand. Reload this. So yeah, this is A 10. This is my address. Let's say 1 2 4. What's that? 1 2 4 4 1 8 9. This is the address of this memory block. Okay, and A is the placeholder. A is pointing to this 10. A equals to 10. And now you assign this A to C. What does that mean? Now C is also pointing to this. Memory location, memory address still stays the same. A is pointing to 10. Now C is also pointing to the same object, same memory location. And how do you find that out? Don't focus on the identity operator. Identity operator again has only two operators. One is and is not. Is means evaluates to true, again true and false. It also returns an output in form of true and false. Evaluates to true if the variable on either side of the operator points to the same object, and otherwise false. So this is, it says if both of these operators, operands, both of these operands are pointing to the same object. What is object? Pointing to the same address. Okay, then it will return true, otherwise it will return false. Simple. Okay, so somebody is saying that time's up. Okay, if you are okay, I'll take 2 more minutes. I'll talk about identity operator, and then bitwise also I'll cover quickly. Otherwise, I don't want to drag it to next class. Okay. So there is one function called ID function. You use ID function to identify the address of these variables. I'll show you. So this is the address of C. This is the address of A. And if you see the address of A and C is same, that means this is happening. They are pointing to the same address. And that's why A is C. Identity operator says, is A and C both pointing to the same object, same address? Yes, that's why you get true as an output. But some underscore D and A, are they pointing to the same address? No, they are not. How did you figure that out? Use ID function, and if you try to print the location of where your sum underscore D is stored, it's stored here. And where was your A stored? A was stored here. So you see the address is different. Address is different. Memory address is different. That's why you get a false identity operator. Clear? Any questions? Shall we move to bitwise operator? I'll cover it quickly. In last class also, I gave a glimpse of bitwise operator, I guess. No, I think we talked about int to bit. Yeah. So is it clear, guys? Shall we start discussing about bitwise, or do you have any questions with respect to identity? Okay, fine, thanks. There's no, as there are no questions around this, let me just quickly move to bitwise operator and talk about it. So let's say A equal to 8 and B equal to 4. So first bitwise operator is XOR, and this is the symbol. This is called XOR operator, and this is the symbol. So you will see the symbol above 6. So in your keyboard you'll have 6, right? Over there you'll see XOR. Okay, I see there. Somebody know. Correct. XOR. Fine. So what will XOR say? XOR says if 0 XOR 1, then it will return 1. If 1 XOR 0, it will return 1. If you do XOR between 0 and 0, it will return you 0. If you do XOR between 1 and 1, it will return you 0. So this is the definition of XOR. Okay, guys. And when we talk about bitwise operator, we deal in zeros and ones. So this is how you represent 8, and this is how you represent 4. So this is binary representation of 8. I talked about this in the last class itself. For those of you who don't understand how to convert this, please have a look and read about it. If not, I'll talk about this in the next class. And this is for 4. This is how you convert 4 into binary 0 ones. Now you might be thinking, sir, how will I apply XOR to A and B? So let's say if you want to do A XOR B, then the output will be this XOR with this. Now if you use the definition that we just understood, 0 0 will give me what? 0. Again 0 0 will give us 0. So we'll have 2 zeros. Then third one, 0 1 will give us 1, and then 1 0 will give us 1. So you get this. And what is this? This is 12. Why 12? Because the single bit represents 8 and this bit represents 4. The output becomes 12. Clear, guys? Oh, somebody saying I am displaying the wrong format. Let me quickly check that. Sorry, it could be. Thanks for highlighting that. Let me try it out quickly. So best way to try these things is try it out. Print 8 XOR 4. You get 12. Yeah, so whatever I was explaining is correct. Okay. Whatever I was explaining is correct only. This is 12. How did I verify that? I tried to do this. 8 XOR 4. And then you see the output. What is the output? It's 12. We also got 12. This is the definition of XOR. Clear? Any questions? Anybody? No? Perfect. So I see a lot of people are not interested beyond the time. No problem. We can talk about the other remaining things, other remaining operators of bitwise in the next class. But I'll try to cover it quickly so that you kind of get a highlight. So this is OR, this is and this is shifts, left shift and right shift. So this is your left shift and this is your right shift. So basically what does that mean is you have this binary representation. This is your binary representation of A, and if you want to shift it by one value, so you will shift it and add 0 at the end, and if you add 0 you will realize it will become 16. So your 8 became 16 when you do a left shift by value of 1. So this is how your operator will look like. You do a left shift. This is your left shift operator. You do left shift and the value becomes 16. Right shift means initially you had this, okay, you had this, and when you do right shift, what do you mean right shift? You are shifting on the right hand side, and when you shift on the right hand side, we'll take 1 0 of yours, and when we take 1 0 of yours, why we take 1? Because you are asking us to take 1. Left shift by 1 bit, sorry, right shift by 1 bit, shift right hand side by 1 bit. You shift right hand side, we take 1 0 of yours, and you get an output of 2. Clear? I see. Let me see. Okay, people are saying, sir, we didn't get you. Okay. Fine, guys, fine. So let me do one thing. I'll cover this in the next session itself. Okay. Don't worry, guys. I'll talk about this in the next session. Don't worry. Okay, people are saying, sir, explain once again. Fine, fine, fine. Okay. Even I'm not able to decide should I take it this time or next time. So fine, I'll take it right away. Left shift and right shift we'll discuss. Okay. Left shift, right shift. Left shift means you will have to shift bits towards left hand side. So think like this. You have these many bits. Okay. And this is your 8. This represents 8. This entire bit. You talk about 64-bit computer, right? 32-bit computer, operating system, hardware, right? 32-bit, 62, 64-bit. So like this, 64 bits are set. So in those kind of computers, if you want to represent 8, this is how you will represent 8. Okay, all zeros, and from here you will have 0. This represents 1. This represents 2. This represents 3, and this represents 8. Okay, if you're not able to understand how this representation comes, you can quickly go and read about how to convert integer into bits. Then you will understand that. That's not something big. For now, just assume that this is how the conversion looks like. When you convert 8 into bits, it will look something like this. Now, when I say left shift, what does that mean? You will shift your 1 here and make it 0. So this is what you get as an output. You're shifting your 1, which was here previously, towards left. When you shift it towards left, this is what you get. And if you try to compute, if you try to convert this binary representation into integer, numerical value, you'll get 16. Is it clear now? Yes, good. Similarly, you had 4. Okay, this is how 4 looks like. Now you want to do right shift by one value. So when you do right shift, what will happen? This will become 0 and you'll come here. You shift it right. So this becomes this. This is 2. This means 2. Thank you. Somebody saying, sir, great example. Perfect. Let's say you have 4 here. Now what will happen? You want to do a left shift and you have 4. And this is your original value. What will you do? You will shift 4 times. 1, 1, 2, 3, 4th. You want it to be here. So this is how it will look like now. And actually, if you see what has happened, and if you see numerically, when you do this, it means you are doing 8 into guys, it might get a little tricky to understand, but for those of you who are able to understand, this will make sense for you. Actually, this is what you're doing. 2 in 2 ki power 4, 2's power 4 into 8, your original value. Original value into 2's power 4, because you have to shift 4 times. So numerically, if you see, this is what's happening. So what is 2's power 4? What is that? 16. So 8 into 16. And what is 8 into 16? 160, 128. Okay, so this is your output. So now you see 0, sorry, 1, 2, 4, 8, 16, 32, 64, and 128. This is 128. Clear? Any doubt? Anybody? Any doubt? Yes, no, yes. Left shift and right shift are the important ones. 0, this and ortho, I guess everybody knows, right? 0, 1, 0, 1. We have already discussed about this, so don't worry about this. 0 and 1. What will give? It will give 0. Let's say if it was OR, it will give 1. So this, so everybody knows. So don't worry about and. Sorry, and this is and symbol. This is OR symbol. So I think this is clear. And we talked about XOR. This is the XOR property, and this is left shift, and this is right shift, and that's what we discussed here. I think bitwise is also covered. Okay, somebody is saying, sir, please explain 120 wala result once again. Okay, so how many times you want to shift your bit right side, left side? 4 times. 4 times I want to shift. So basically add 4 zeros. That's it. That's what you're doing. Am I making sense? Now somebody says, sir, shift right hand side 2 times. Remove 2 values from the right hand side. That's it. This is what will happen. But let's say this was the original value, right? This is what will happen. Final answer will be 1. Clear? Somebody is saying, sir, discuss right and left in the next class also. Fine. No worries, guys. No worries. For those of you who understood this, it's good. Let me stop here.